practice today's R script. I'm not sure if all of you have RStudio already. We are going to use RStudio to open this R script, and it will look like this. So if you don't have R and RStudio installed, just watch me to do the demo. It's fine, or use any of the desktops in this room. So don't feel frustrated because loading big data could be a long time. And just watch me. Then you don't need to feel very painful on your own machine. And except the 3 TXT files, I share my PowerPoints with you, which is here. So you don't need to worry, you don't have the slides. And inside the data documentation folder, that's very important for everyone when we are dealing with real world data. Without data documentations, we are not able to know anything. So I have 5 PDFs here. But just for your information, the raw materials I downloaded from FEMA will look like this. So you're going to see more PDF files and more data sets like this. So last semester when I teach this, I think attendees feel very overwhelmed about those files. So that's why this time I only give you selected data files we are going to use today and the data documentations for your references. And because it's 412, let me get started. I know some of you are still downloading the file. That's totally fine because I will go through my slides and you are going to have tons of time to download the slides, the TXT files, and R script. So just look at this link on the whiteboard. So I'm going to move to the outline of today's workshop. As I mentioned, we are going to use FEMA data. So the NFIRS is the National Fire Incident. I don't know, maybe registration data or something. So it's the fire incident data for the whole country. And I will only use the 2024 data sets as an example. If you are interested in 2023 or other years, feel free to go to this link and you are going to find all the historical fires from FEMA. This is open access data, so we don't have any copyright issues. Yeah?
Sorry, this website isn't working for me. Is it just me?
Doesn't working for you?
It works for me.
Is HTTP or HTTPS? Doesn't matter, okay.
I have a question.
Yeah.
Will this be available online in the YouTube later?
Will it be on YouTube later? Or yeah, it will be on YouTube.
If I miss something, I can go back to it.
Yeah. Or just reach out to me. Like I didn't introduce myself, but on the first slide, I think everyone knows my name is Wei Ying. I'm the Research Support and Data Services Librarian at Research Data Services. Here are 3 of my colleagues in the same team, Mozilla, Eric, and Jeremiah. Some of you came yesterday for Mozilla's Python session. Eric will give GIS workshops next week. So if you are interested in more things, I have a slide, which is the last slide of this whole slide deck. You are going to find how to go to the Data Club session page. So today, I'm going to talk about the large data set in R. So when I'm talking about large data set, I don't want to give you a very fixed definition because nowadays everything changes very, very quickly, especially for our computers. Maybe 5 years ago, a lot of computers, especially laptops, you only have 8 GB RAM for your memory. Nowadays, I think many of, if you are new students, get a brand new laptops, you probably will think 6 GB or 32 GB will be the minimum those vendors can offer to you. So the large data set definition is here for your reference, but I would say most of those information could be out of dated. And that's why last semester I gave a talk on this topic, and today I'm going to talk about some updated thing. And I'm glad we have a mixed group, someone from engineering CS background, some from social science. I don't know if any of you from science background or what is your background? Sipa. And how about you, Sipa, the same?
I'm not actually an undergrad here in Columbia. I'm an exchange student.
Mhm.
I'm doing economics and finance.
Okay, so social science.
It's more like business.
Business, yeah. So yeah, I'm glad we have a mixed group today. So many people nowadays thinking about programming, especially if you use AI to help with coding, you usually get answers from a very engineering perspective. But actually, in my opinion, because I work with many social science students, you don't really need a very engineering style coding. And my 2 hour sessions are trying to deliver that kind of opinion. So I'm not saying I'm correct, but because most of you come here for your curiosity, so I want to provide some perspectives which are different from your textbooks or what your professors will teach you. That's very orthodox way to learn knowledge. And Data Club try to give you some options or possibilities. I show you what I think about this, and you can have your own opinions and share here later, or anytime, just hands up if you want to make comments or ask me questions. And what I'm going to talk about today is, if you look at this kind of data mining workflow, where is R will be used? R will never be used as a database management tool. That would be SQL or something else, right? And most people, if you use R or even Python in academic setting, you use it for data analytics. And that means for statistics, analytics, or even evaluation. So that's our focus today. But when we are dealing with large data, usually our local computers cannot store it. Then we have to go back to that step about database. But many of people, if you don't have a CS engineering background, you probably don't know database system very well. And when you are dealing with database-based data sets, you will have a headache to think about how to deal with it. If I don't want to link to a cloud-based service, or I don't have resources using those cloud-based computing, what should I do? I have a Python or R on my computer. I know how to use it. That's why I want to design this session. And when I mention large data sets, it's not big data using high-performance computing. That's my COIT colleagues' workshop. And you are welcome to search on COIT's research computing services dataset. They have a long list about HPC and other services. You can learn a lot of those resources through their workshop training. What I'm going to talk about today, the large data sets are real-world data, mostly in sciences and social sciences scenario. So what does that mean? They are not perfectly simulated scientific data. So they are collected data, such as the fire incident data we're going to use for FEMA. So that's a volunteering reporting system. Even you think that's a national survey data, no, not survey data, national reporting data. FEMA made it very clearly, don't think that's a census-style data. So they collect data based on the collective initiative from all those fire departments in every village, town, or city, or state. So if that is the case, human interventions there, you are going to see there will be some problems in those data sets. So highly possible, we need data manipulation. So this is the first thing. And secondly, some people might use FEMA data for some reason, for some research hypothesis, but you probably want to combine several different data. For example, census data, FEMA data, and climate data come together, build up your own data set. So definitely, it's not a well-cooked database you extract from the virtual end, then you can use, because you are going to do some your customized research exploration. That is exactly what I want to demo for you today. And again, I aim for standalone individual machine users. So how can we download those large files and do some exploration, then make a decision? I really need a large-scale data computing. Then it is the time to go to HPC or cloud-based computing. Or I'm totally fine. After subsetting, I'm quite satisfied use my desktop or laptop to do it. And I'm not going to talk about automation and iteration today. That will be, for example, I have 10 years FEMA data. Today I show you 1 year. How to do 10 years all together in one shot. I will have another session, repetitive data tasks, next Thursday at the same time, talking about the automation iteration thing in R. So now I'm talking about my ideas about a few solutions. And I want to give you a reminder. This is just my personal opinions. You can disagree with me or challenge me, ask me any questions. I may or may not have answers. And also, I talk about this today, and those solutions can be changed very fast. Maybe next semester in fall, I reteach this session, and I will change the content a lot due to the hardware and the software improvement. So there are two real-world data examples I want to highlight here for your information why this is important for you to know how to deal with large data set, even you are not engineering background, CS background people, because real-world data is very big nowadays for every aspect. So this is the website from the Open Data government from Seattle. So this is Seattle's public libraries checkout data. You're going to see this is a very big data set. They have almost 50 million rows for, I think, many, many years checkout information. You're going to see the latest update is January 6, 2026. And the next question will be, if it's 50 million data, can I download it? Or how to download it? That's very normal, like regular people. Even you are not student, you don't work with R, don't work with data, you might have curiosity, you want to do it. So there are a bunch of actions on this user-friendly interface will help you to do everything in different levels. For regular people, if you only want to see a little bit about what does this data look like. So this is the basic interface to give you maybe 10 or 20 rows. You can scroll down a little bit to know what is the data. Like this is very straightforward. However, if you say, I want to export, I don't want to use this interface, you probably are more interested in export. But immediately they will tell you, yes, there are several like export formats for you to consider. They give you a warning. This is a large data set. You are not able to download everything, especially if you are Excel user. I think Excel definitely can only download maximum 1 million row or something. So 50 million row can never be done in spreadsheet, no matter it's in Google Sheet or in Excel or something. So they will help you to think about, you can add in the filter in the data tab to reduce the size before downloading. So that is the thing. For regular people, maybe that is fine. And if we have time later, I will show you one way you can download it through R or Python. You can do it, but it's not through this interface. You need a little bit coding skill. The other example will be the data set we are going to use. That is the open FEMA data for fire incident. And on the FEMA data set, I want to load this data set to let you know I didn't put everything, every information on my slide. So you probably need more information to say they introduce you API way to download open FEMA data, or you should consider about this tool, that tool. But basically, for very big data sets, OpenFEMA limit the download format type to CSV. So that's why you are going to see we have a TXT, which is not CSV, which is very interesting. You probably need to consider government data is like They give you data documentation, but sometimes you really need to dive in a little bit, then find slight differences and customize to it. So for using the data, they will make it very clearly that you probably cannot use regular Excel or other things to do it. You probably need a database thing here, or use Python or use R or use other tools like Julia, etc. to do this thing. And today is the R demo session, but feel free if you want, you can use Python, you can use Julia and other like computing software package or languages to deal with it. But I highlighted those like main points FEMA tell you. Download only what you need. Don't think about your database manager because most people use data for a purpose. So you are not manage data, you are data user. So we talk about things from a data user's perspective. And also, today I use 2024 static data, but you have a question. Maybe this is dynamic data, and if I want to update 2025, 2026, how to do it? Next Thursday, I probably will have a chance to talk about using API to download data. So that's very much an iteration question or data problem. So I will skip that question and talk about use tools like today to deal with large data set from FEMA. And they also tells you, you probably need to seek additional resources from the web regarding data science, data wrangling, and data analysis tools used to work with large amount of data to encourage you think more creatively. And I'm going to talk about our packages rather than like coding from scratch, because even though that's a golden standard for computer science or engineering background people, most of people use R is not aiming to be a R programmer. We are R users. And the best thing for our community is, this is a very matured user community. A lot of people contribute great R packages. I only picked a few of those packages here for your information. You can find much more packages in different disciplines, in business, in science, in social science, to deal with large data set. But today I'm talking about darkplyr, Arrow, data table, dtplyr, dbplyr. They are very general packages for every discipline. It doesn't matter which major you are in, you can use them without any discipline like knowledge barrier. And I don't want to talk about polars. That's because actually Mozilla had a Python polar session last semester. I think you can find the YouTube video in the Data Club YouTube channel. So I will skip polars for today. That doesn't mean polars is not good. I also give you a polars link on this comparison chart. The reason I don't want to talk about polars in R is because now there are two different R packages, one called polars, the other called tidy polars. And I think they are still under the version 1.0. Today, I will only talk about matured packages, all the version numbers greater than 1.0. So that means they are very well cooked packages. So it doesn't matter data table, Arrow, or duckplyr. They are all above 1.0 because that means, like from an engineering background people, they think that's okay, well ready to be used by everyone. Maybe you have less bugs need to fix or something. The first one, data.table, I will show you at the beginning of my R script to tell you, it used to be a very useful package to deal with large data in R. They have a famous function called fread, fast read. However, this is mostly ideal for CSV file, but today we are going to deal with TXT file. So that's a text information, very heavy data. So for CSV file, they are mostly numeric based. So it will be very nice to be handled by data.table if it's less than 2 gigabyte, I would say. For everyone, it's safe to use fast rate to import those type of CSV. However, it will not be very good for like JSON file or Parquet files we are going to talk about later today. And if you want to use data.table, I would also recommend you to consider something called vRoom. And the reason I give you the vRoom page is because they have a really good benchmark here to compare, including data.table, vRoom, and a few other R packages when they import data, when they print out data, how long or how much memories do you need on your local computer. So this could be good for medium-sized files for your consideration. And today, I'm not going to focus on that. Today, I'm going to focus on number 2 and number 4. I mentioned for number 5, R and Python can do. Polars is great, but we will skip that option for later and go back to Mozilla's YouTube video. And why I also highlight dbplyr and dtplyr, that is because these are very, very traditional database-based R packages. However, I don't think everyone here really knows SQL very well. If you know SQL very well, you might have a question, why bother to use R? But the actual situation is many people just never get trained in SQL. SQL is not very hard to learn if you want to learn, and it will be very useful, and that will be my final conclusion. However, if you are R user, you still look for some solutions. That will be, in my opinion, number 4 plus number 2. So it's Arrow plus duckplyr. Why? That is because for Arrow package, we don't want to introduce too much background information, but it's very easy for you to convert any TXT file, including CSV, into a Parquet format data. So once your data convert to Parquet, that will save your memory. So that will be our first idea. If you have very large file, reduce the size will be the first thing to do. And the Arrow package can help you immediately to convert it into a much smaller Parquet file. And the nice thing is both Arrow and duckplyr can import Parquet very quickly and do data analysis. And you might have a question is like, why bother to learn duckplyr? That is my unique case today because I realized some shortage only use Arrow. But mostly I would say for numeric-based file, Arrow is good enough. If you read R4 Data Science online book, they only talk about Arrow and the database together. And duckplyr is a little bit new because it's from duckdb, another database management system. So the reason I introduced duckplyr is because for any R users, this package uses the Tidyverse grammar. So Tidyverse is the core packages in R. So if you are R user, you will never avoid to use Tidyverse. So if anyone, you know the grammar of Tidyverse, you have no problem in understanding what duckplyr asks you to do. And I will show you my R script. If you have already understand R language, you won't have any problem in digesting. However, if you use dtplyr, these are very SQL language, then people will be like, oh, this is a foreign language for me. So they will feel like very panic. So actually, they are equivalent. And if you know database, you know SQL, your life will be much easier. But now, because of Arrow and duckplyr, I think all the R users, no matter if you know data engineering or database, you can deal with large data set in your local computer. So again, today's demo will use OpenFEMA Data 2024. You can download the data through the link. And we are going to try to use Parquet file and duckplyr's function to do a little bit data exploration. And before I go to my R demo, I give you the link for data club session here. So you can go to this link tree and find the other data club sessions. If you have any questions related to today's session, you can email me directly or email Research Data Services. And I will go back to the download link just in case someone is late and you didn't get the data file. If you have downloaded the data file, or you can look at the whiteboard to download the zip file, which is called bigr26.zip. And after you unzip it, I hope everyone you have 3 TXT files, 1 R script, 1 R slides, which is r.pptx, and a data documentation file. So I want to stop here and double check if you need help in downloading data or load your data or R script.
I have a question.
Yeah.
Are we going to use R or R Studio?
R Studio.
It has none here, and it is asking me what do you want to download, R or
R Studio? Yeah, that's a good question. I would never recommend people use R for interface. I think R Studio is the reason people want to stick with R, because R Studio's interface is very user-friendly. And for your convenience, I highly recommend you to just open your R script inside this folder, because once you use this way, your default working path will be in this folder. Then you don't need to worry about working directory, working path issue. So that's what I did. So if I open this R script in R Studio, so the first thing you can double check is in the console, you will see currently my working directory is this folder. So I can also do get WD, right? And in my console, you are going to see currently I saved a folder called Working with Large Dataset in R Spring 2026 under my download folder. So that will be our default. So every single time, so my R script, if you see I read the file basic incident.txt, that will be from this folder. You are going to see basic incident.txt, which is 6.67 gigabyte in my folder. So I'm going to use this one to show you the differences between different packages. So if you don't have Tidyverse, data.table, arrow, and duckplyr, please run line 8 so you can install all the packages in one shot. If you don't know if you have it or not, here is the package tab. You can search anything, for example, data.table. If you search it and you find this package, that means you have installed it in your R environment. If you don't have it, you can use install a package or click this install interface and type your package name here, like data.table. Then you can install. So because I have installed everything, so remember, you only need to install packages for one time. And after that, every single time you use it, you call the library name. For example, now I'm going to call the library data.table to show you how slow it takes for you to load that 6 gigabyte TXT. And one more thing for your information is the separator here is a caret. And how do I know the separator for this TXT is a caret? I don't recommend you to use any text editor to open it, because that takes forever. This is 6 gigabyte. So there is no way for you to have a double check. And I think someone will be like, oh, but you have a causes.txt. So that one, probably you can open it very quickly and see that caret as the separator. But I highly recommend any of you, if you download data from a website, there will be data documentation. So you are going to find those data documentation either from the data analysis guideline, which is 73 pages. I'm not going to go through with you like page by page. Or, for example, this is the 2024 data. So they are going to give you a lot of notes related to the specific year data. And for this 2024 data notes, they make it very clearly the file format separated by the carry character. So you should keep in mind, always check the data documents so you will know what kind of data it is, because there is no other way. In this scenario, we can double check. You cannot import in Excel, you cannot open it in plain text editor, and the only way to know a little bit before we see the data in our environment is to read those data documentation. And for this file, the public data release format document, you are going to see this is the basic incident.txt, and it looks like we are having 42 columns to import. And I believe in another file, you are going to see this is a 33 million row file. So this is a very huge file. And if you want to know how to use the fast rate, F rate, from data table to run this file, this is my code. And you are going to see it takes time. It takes a lot of time, and you see that processing. And usually on my own computer, either this laptop or my desktop, which is a Windows machine, I need at least 1.5 minutes. So it's like 90 seconds or above, sometimes 120 seconds or above. So it depends on different laptop or your workstation's environment, your RAM, and your storage, or the infrastructure, like hardware thing. So you are going to see, because data.table is memory dependent. It's like highly demand on your own computer. So you are going to see later when this basic underscore F rate item showed up in my environment. Now my environment is empty. Highly possible the size will be more than 10 gigabytes. So this is not a very efficient way. This is not an economic way to import your data. Your original file is 6 gigabytes. That is way much bigger than we want to have. But after you use f.read, you're going to see I used my user system in the console say you used 160 seconds to load it. And meanwhile, you will see the real size for this 6 gigabyte local text file in my environment is 10 gigabytes. So this is not a good option to deal with my data today. Again, data.table might be good for your medium-sized data, but not for this type of thing. So there are different ways to deal with the next steps. So first thing is, if you click this button, this is the pie chart to let you know how much free unused memory you still have in this environment. So if you want, you can do GC. So that's garbage collection. So this is kind of like I want to clean up all those memories, try to maximize memories I can still use. And the other way to do, and for me, I will definitely remove everything because I don't want these 10 gigabyte items bother me, and I want to do a restart. So because I don't have anything, it's very safe to restart. And once I restart my R session, you're going to see everything just like your restart your computer. You're going to be like memory free, go to the next steps. Any questions so far? We are going to move to Arrow and duckdb, duckplyr, and see why I still think Arrow is not enough. In this case, maybe we need both duckplyr and Arrow. So after I restart my R session, I want to try firstly the Arrow package, because Arrow is, yeah.
So I ran the same code, it took longer.
Yeah.
And what determines?
That's like how old your computer and your RAM, your memory, and also we just had a very brief discussion. Different brands of computers, they use different chips that will also have some differences, but we are not going to promote any specific brand. And the purpose for today's session is to encourage people to think about just utilize your own machine to deal with some large data sets. So I think because of the software is also improving. So don't feel like, oh, I don't have a fancy machine, so I cannot do everything like this. I also have an old MacBook. It's like 5-year-old, 6-year-old, so I don't think it's that fancy. But to be honest, if you have a 2025, 2026 MacBook, you probably only need 30 seconds or something, and I use the 160. So this is something definitely you need to consider about. But the other way to think about is you not just have your own laptop, you also have those CUIT machines on campus everywhere. They can definitely run much better than any of our local machines, I think, like laptops, I mean. So I want to expand your ideas to think about your data issues. You can take advantage of everything, like resources on campus, workshop, IT's machines, and also those packages, they are coming every day and keep doing some updates. So definitely keep updating what you know today. Maybe in half a year, some package come out and totally change the game. That is the information I want to deliver here. I don't even know in fourth semester if I will introduce these two packages or there was something much more fancier we should learn and keep in mind.
But even more important than the time it takes is the fact that the file, once it's loaded into memory, is 10 gigabytes. And that's sitting in memory. So it's threatening making your computer choke. So you want to use strategies that lessen how much memory at any given moment. So, more RAM makes things faster, but also makes things more possible. But there are limits on how much RAM you can have, especially these days when RAM is ridiculously expensive.
Yeah.
So these are strategies to get around these kinds of like physical limitations.
Yeah, exactly. So I think when I run the same R script last semester in October, my computer performed much better. So even in half year, I think that's also related to the computer thing. And also, but you will see, we just compare within the same machine using arrow. I used 28 seconds to load the same TXT file. But if you use data.table, just on my machine, it's 160 seconds. So that means strategically, if I still have this older and older machine, I would prefer, firstly, use arrow for sure. DuckPlayR, that's a later story, right? But so far, when I compare these two packages, in this case, I would recommend to use arrow to load it. However, there are some other problem. So far, we didn't see arrow. We didn't see warning message. So you probably think this data file is okay. I will show you this data is problematic. Until you see the data, you cannot trust everything is okay. So that will be the next step. So after I load it, I call it basic arrow. I want to save it on my disk. So you are going to see how large it is in a packet format. And usually, based on my testing on my machines, they are around 940 megabytes to 980 megabytes. So comparing to 6.6 gigabyte, packet is definitely the ultimate goal for now for everyone to think about if you have a larger size data. If they are not in packet size format, try to change them, convert them into packet format. So that's something kind of definitely a correct choice. Even for polars, I think polars also like packet format data file. So after I write my packet, you are going to see in the same folder, there is a basic.packet, which is 984 megabyte. It may be smaller, or larger on your own computers, but I think it's in this range. And based on this, I think the basic underscore arrow is done. And now I want to use duckplyr to import the local packet and show you what is the problem I find. So far I didn't see any problem. However, one thing is, probably for your information, is some of the R users like to do the preview of this table, use this table icon. I don't think this works because we have more than 33 million rows. If you click that view window thing, it will loading, and you will get crash. So that is a bad idea to double check if your data looks good or not. We definitely remove this item, and we will restart everything so that we don't need to worry about the R will crash down, because so far we are trying this way, that way. And don't feel frustrated, oh, I need to restart again and again. This is kind of an experimental session. So I show you all the possibilities. But once you know what is your choices, you don't need to restart your R sessions all the time. So I just show you all the possibilities. Now I will try to use the duckplyr, which is duckdb's Tidyverse version, to load my local basic.packet file. So I don't think you will have any problem in understanding this function. So the function is easy. It's just say read packet duckdb. Then you will see you don't need to worry, oh, loading. So immediately you see that item. However, you are not going to say how many observations you have. So probably you want to double check if it is the same number of row, and you get exactly the 33 million row, the number of row. So okay, the first thing is you checked it, and you think, oh, this is correct. The arrow gives me a correct packet file. But I also recommend you to check the structure. And probably you are going to find something is not very correct. So until you see the real data entries, you cannot 100% sure if every single row and every single column, they look correct. So that's why I try, even though it takes a couple of seconds to look at my structure, I think it's worthwhile, and that's what I missed last October, because I think, maybe everything I should trust Arrow, because Arrow is a very matured package. They should detect every single column in a very smart way and in an accurate way. However, for this TXT file, I will show you what's wrong. So when my R is still running, let me come back to this data format. So for this data format, I want you to look at the column 4. For column 4, this is the incident date. And they tell you this is a numeric data type. And actually, if you think about this is MMDDYYYY, it looks like a numeric information. However, if you want to use R to do it, you will have something Arrow also had the trouble in detecting. So look at my console. For this column, incident date, Arrow changed it into integer. And what does that mean? So for January 1st, 2024, it becomes 7 digits. That's a trouble, because even the original data format document tell you need to have 8 digits. Because if you missed that leading 0, later you are going to have trouble to convert it into the real date format. We have a Lubrate date format package for R to use. When you are dealing with date calculation, you need to use the MDY format. But if you now have an integer 101 2024, that becomes totally numbers. That's a warning for you. Is it correct or not? That may not be correct because I think the safest way to keep that leading zero is to compare with if you have 11/01 2024, right? So November 1st, 2024 and January 1st, 2024 should be the same data structure. So the best way for our situation to deal with that is when you import text information into your data environment, you make every single column with that issue as character. Then later it's very easy for you to do s.numeric, s.date, s.whatever. So that will be easier. So for this type of very complicated data set, even though some of the data type they defined for you, like what is X? I think X means a mixed thing. They have fire department ID, so maybe they sometimes have letters and combine with the numbers. And for the character, that is definitely the character information. So now I'm a little bit worried about the other columns, but again, this is a huge, huge data set. I cannot double check every single column. And based on very limited values I can read in the console, I just worry about maybe I also missed other mistakes. So for me, the very stupid and conservative way is when I import everything, I just temporarily regard them as character. Then later, once I confirm this is numeric, this is integer, this is logical, I can convert them back. And they definitely have a logical column, which is here. This is the resource includes mutual aid. So they call it Y. And they say the digit number is 1. So I think that's a yes or no or 1-0 thing. So that's what I'm going to do is I want to re-import this data set. And I want to make a one-shot sub-argument, convert every single column as character. However, in Arrow, I didn't find that sub-argument. But for duckdb, duckplyr, I see that option. So that is why I want to use duckdb. And why I don't use duckdb directly, I give you an alternative wrong thing here. That is, if I only use duckdb and say the delimiter is the caret, I will get a lot of error. And they won't allow me to import this data set. And the first thing I did, which is very stupid, is I say, oh, please ignore any arrows. So ignore arrows equal to true. And when I calculate the number of the basic, you are going to see is I only get 27 million rows. So there are many millions of rows because I ignore arrows, then they are gone. And why that is the reason, again, for our users, you need to remember, for text information in TXT file, they allow you to put all different type of mixed information in the same column, as I mentioned. However, for duckdb, they are very strict. So once they detect under the same column, you have letter, you have number, you have none, you have NA. So for example, there are some crazy columns, they have NA, they have no, they have U, like unknown, they have UU or some other values. DuckDB will be like, oh, this is wrong. I don't allow you to import because this is not a good quality data line. But for now, we just want to get the raw data into R. So what we are going to do is, as I mentioned, I want to fix that arrow. The arrow is if I convert every single column into character, because it's text file, we should be fine. So I will add this all var char equal to true. So that means all the variables will become character. So there are pros and cons. this is a very lazy way for me to just import everything without dealing with manual coding for specific column, because so far I don't really know how many columns I need to recode as character. And also, this FEMA data has a very special encoding. So the general mainstream CSV encoding is UTF-8. I think that's like more universal nowadays. But through the data documentation, if you go back, they make it very clearly the encoding is Latin 1. So that's why, again, I emphasize data documentation is very important for you to dig out those messy information. And after I put everything here equal to true and encoding equal to Latin 1, I can simply just run again. But something will happen is, let me double check the row firstly. So the downside would be, if I only use arrow to create the local packet, the size will be smaller because many columns saved in integer or numeric information. And once you convert everything into character, that definitely takes a little bit more of your storage. So this is pros and cons. It's a trade-off. I want to get accurate information, so I think I'm fine to take this strategy for now. And now I want to double check if I did something correct, because this is some row I fail to load when I say ignore arrows equal to true. So this is an error row, and the thing is, because of the alarm, they tell you the entry is no. But according to the code book, they say for the alarms, that's a yes or no, 1 and 0. So you should have, yes, this is an alarm-based incident, or this is not an alarm-based incident. And for this entry, very weird, they give you just a no. So I give you two code chunks you can try. I only try this one because I want to show you this no case. However, if you run a little bit bigger, so for example, if I pick, this is AK Alaska, the 23200 is that fire department's ID. So for that specific fire department, for everything they input in the system, they give you very unique values, including NA, including 1, including no, and including 0. So for this type of thing, the next step is for your information. If you want to study in Alaska, how do you deal with the no entry and NA entry? Do you want to keep them, or do you want to delete them, remove them? So that is why for data exploration, sometimes you feel frustrated to load for everything, but also this is a thinking process for you to evaluate, do you really need it or not? So I want to, I think I forget to refresh my memory. So that's why it's loads very, very slow. And I probably will stop it. And I believe some of you will see that no immediately if they come out. And let me move a little bit further, is I want to save it on the local computer so you can compare. I believe this basic chart.packet will be slightly bigger than the original basic.packet in my local. So now you will see the basic packet is 980 megabyte. But I believe once the character format packet saved on your local, it will be much bigger, like 1 gigabyte or 1.1 gigabyte. As I mentioned, that's because text information will take more spaces and storages. And when we are waiting for that, feel free to ask me questions, or you have any comments, opinions. Because the final goal is, once we save the correct packet in the disk, then your life will be very easier. You don't need to worry about this loading thing. But now, because we are doing data exploration, we detect the problems, then you are going to find, and hopefully we will still have time to talk about the other causes. And the causes file also has a problem. So hopefully after we write down the basic char.parquet, we will be very smooth. Just import that and compare with the causes.parquet. And you are going to see the two original text files, they each other have their own problem or contradictions. You need to be careful if you want to join the two tables together. Maybe I just flash my R. I think that will be easier. So that we are going to get it in one shot. Let me redo it very quickly. So in this time, I will just come back here, load darkplyr, and get the duckdb, and save it on the local. Yeah, so because I didn't clean up my memory, so that's why we waited for very long. But once I decide this is my strategy, it will be very fast. Wonderful. So the good thing for this duckdb option is immediately, not like arrow, you cannot see what's going on there. You are going to see, once I save it in character format for every single column, it's 01/01/2024. So good. This is exactly something I want to have. And now, let me do the same thing for the causes. The causes is just 24 megabytes, so I don't think we have any problem in save it on the local folder. However, this is a problem I want to show you. If you look at the same incident date, even I convert it into character, you are going to see for the causes, the parquet, they only have 7 digits for the January 3rd, 2024. And why that happens, that is not the programming problem. That is the original file. So the causes.txt for this column is corrupt. So that's not our problem. But we need to detect when we explore our data set. Because if later you think about, oh, I want to link the incident date from the causes.txt with the original basic incident, look at here. This is 8 digits. Then we are going to have trouble. And I have a side note. I can double check maybe in the terminal using the same idea is, if we copy paste, let me copy paste this causes.txt into my download folder. That would be easier. Then I change my, I think it's CD. That's downloads. So we can use this command line to double check. So the command line here is basically, if you don't understand, that's fine, to just print out the 4th column, which is the incident date column. So I want to know the unique length. So you are going to see many rows, they have the length equal to 7, and less rows than that case, they have the 8-digit. So that, like double checked, it's not our coding problem. That is for the original data file. Even you go back to this public data release format document, the last page, you are going to find the data structure for causes. And the very funny is they say incident, the length is equal to 8. So that means we didn't do anything wrong, but there is something wrong with this original TXT file for your information. But you don't really need to worry. You cannot use it in a correct way because anyway, they give you this primary incident key. And this primary incident key will combine everything in the following column together as a key. And if we go back to double check here, you are going to see the funny thing is for the causes incident key, they include the leading 0 for the causes. So one flag is if we use causes.txt for our later data analysis, for my data exploration, my conclusion is don't use the fourth column. But it is still okay to join this packet file with my basic file using the incident key. So that is exactly what I did in the following lines to do. I think we are kind of running out of time. Maybe let me double check if I saved both of them in my working directory. Yes, I have basic underscore char and causes underscore char. So that, very good, I can get rid of both of those items and refresh my R. Then now, for the drawing side, life is very easy. We just load darkply R again, and very easy to load these two packet files. And when I want to join them together to know the causes for each incident, you're going to see for more security reason, I want to link all the similar thing, stay equal to stay, FDID equal to FDID. The reason is if you don't do this to match them, then later you are going to say stay.x, stay.y. That will give you more columns for your outcome. So let me just join them together. I only exclude the insay underscore date because that's a wrong thing to join them together. So when I run it, and I want to print out, of course, because when you do an inner join, you will only keep those rows from the causes data file. And you are going to see from 33 million rows, you only have 300K rows for the joint accident. That is because the causes is only for the structure causes. So it's nothing related to other causes. So again, if you want to use the causes.txt, your final data format is not a large data set anymore. So that's another thing I want to keep you in your mindset. Sometimes you probably don't need many rows later for your data analysis, but dealing with large data sets still your primary procedures. And when I print out all the column names, you are going to see what I say. If I don't join the inside date together, you are going to see an .y and .x somewhere. So that means you have one inc date from your left data table, and you will have another inc date from your right data table, that one you join in. Actually, this is very good. So you need to keep in mind these two dates, they are not exactly the same. The stay equal to stay, that means they really together, they are the same stay. So that's why you will only keep one stay column. So sometimes in order to reduce your data storage, you should not keep the redundant columns. That's what I did here. I did the similar things, no, the same, exact same columns, leave it only one time. But for the date column, because X and Y files, they are different, so please distinguish them. So this is very important before you do the other data visualization or statistic analysis. I think I delivered my main points here. And the last 1 minute before Q&A, I want to show you the reason I didn't introduce you duckdb and DBI directly again is because I doubt everyone here really knows database or SQL very well. But if you want your life in a very easy way, still using R, your final goal should be duckdb library and DBI. So these two can help you without any of my frustrated moments just now. So if you just say, oh, I load duckdb library, this is an R library, and I load the interface for the database, that's the DBI, and I connect with duckdb, then I use some duckdb or database languages to load exactly the same read CSV or read TXT function. You're going to see immediately. So you don't have any pain. So it is totally up to you. If you really don't want to wait for any seconds, these two will be your ultimate goals. But I believe most of you come without database knowledge. You still want to be very close to the Tidyverse grammars. Then darkploy-R and arrow packages are good enough for you to deal with today's issue. And these two could be your advanced learning by yourself, or just feel free to take a database courses, then you probably open another door to solve this problem within R or without R. So I think I will stop here, and feel free to run the visualization for fun, but I don't think that's related to today's topic. And I'm willing to hear from you, and feel free to give me your comments, opinions, or suggestions. Any feedback would be appreciated. We have a survey there. If you have 1 minute, please fill in the survey, and we will read and evaluate and try to make this session much better in the next time. Thank you. Yeah, just let me know what you think.